Hello. Hello, hello. Guys, सीन क्या शॉर्ट हो रहा है क्या? Dynamite is live. हेलो गाइस. हेलो. क्या चल रहा है? क्या चल रहा है गाइस? सबसे में 15 क्या चल रहा है, क्या चल रहा है? सीन बड़ा बड़ा फट रहा है। हेलो हेलो हेलो। Oh, I like it. Subscriber seat solve कर रहा हूँ guys. I don't know.
So before starting this video, I'd love to thank Relevel for sponsoring this entire video. A hiring platform with no degree required, no experience required, mentoring sessions available, feels like a dream, isn't it? What if I say all of this is for free? Well, Relevel by Unacademy is here to make your dream come true. With job opportunities in practice, market and business development from India's top companies for freshers and people in the early career. Relevel is here to make the entire hiring process super simple and super quick. All you have to do is to give the Relevel test, and based on your score, interviews of any given binary tree. So let's assume this is the binary tree that is given to you. So bottom view, as the name suggests, you have to look from the bottom and imagine this tree in a 1D, like in a 1D paper. So what node will you see? The first node that you'll see, like from the left to right, that will be 4, right? From here, I think you'll just see 8 because 8 will be hiding 2. So you'll see 8. And if you look out from here, the node that you'll see are 2 nodes. Basically, from 2 there is a node 5, and from 3 there is a node 6. So there are 2 nodes. That is the case. Always make sure you take the right guy, like whichever guy is on the right. That's 6 is what you're going to take. Okay, so that's why I've drawn it on green color. You're going to take the 6th node. Instead of 5, just make sure you take 6. If you look out over here, so that's the node 9, which is covering 3. So there's node 9. And if you look out over here, that's the node 7. So the bottom view, is going to be this 4, 8, 6, 9, 7. So in order to solve this problem, we are definitely going to use the concept that we learned in the vertical ordered traversal, right? That is the line concept. If you remember, we learned a line concept. We are gonna use that. So we'll be using the level order traversal. So the concept that we did learn in the vertical order traversal was to draw parallel lines. So like on imaginary, I can say this is one line and assume this is line 0. And the moment you move to left level, what you'll do is you'll try to have it on a line -1, like if you move to the left. And if you're moving to again left, please make sure you have a line -2. And similarly, if you're moving right, just make sure you have a line of +1. And if you're again moving right, just make sure you have another +1. So what I can say is, on every line, like on every horizontal line or vertical, whatever you call it, on every this line, the last node. So the last node is 4. On this line, what is the last node? That's 8. On this line, there are multiple last nodes, 5 and 6. So you'll always take the one that comes like from the right, that's 6. And on this line, you have a 9. And on this line, you have a 7. So what I can say is, I can actually do a vertical ordered traversal. And I can figure out the last node on every vertical order. And that last node will be my bottom view. It's indeed right. So let's try this out. So what we will do is, we will initially take a Q data structure, okay? And in this Q data structure, we are going to store the root of the tree. And initially, we will have the, like, because this line will be 0. So we're going to store 0. And at the same time, we are going to make sure that we take a map data structure, okay? And in this map data structure, we'll be storing the line and the node. This is what we are going to store, okay? So please make sure you take map data structure so that it can store sorted lines. Basically, the -2, then -1, then 0, then so on. So initially, you start off with the node 1, okay? So when you have the node 1 and you have the line 0, please make sure in line 0, insert a node 1. That's what you'll do. On line 0 key, you will insert a 1. Okay, so that's what you've done. So once you've done this, on node 1, what is the left? Left is 2. So you insert that into the queue. And can I say if I'm moving left, the vertical will be -1. So 0 -1 will be -1. So you put that on the left. And you have on the right, that's 3. So can I say the vertical will be +1 on the right? So I'll make sure I'll put that into the queue data structure. Once I've done this, I can say for node 1 it is over. So that's over for node 1, right? So the next iteration I'll get node 2. So the moment you get node 2, the line is -1. So please make sure on -1 you have the node 2. Perfect. Right after that, for 2, check the left. Left is 4. So do a -1. So you have a -1 over here, right? The node had a -1. So you do a -1, you get the line as -2. Perfect. And on the node on the right, you have a 5. So you insert 5 and it was -1. So -1 plus 1 will become 0. So I'll make sure I'll insert 5, 0. So I can say this is done. So node 2 is done. So let's take the next node. Next node is 3, +1. So 3, +1. I have a node 3 +1. So on line 1, I have a node 3. That's the last node. So of 3, on 3, the left is 6. On 3, the left is 6. And if it is 1 and you're going to the left, so -1 will be 0. And on 3's right, you have a 7. So if you're going to write 1 plus 1, that's going to be 2. Perfect. So 3 is done. Next, you get 4, -2. 4, -2. So if you're standing at 4 and your line is -2, so you can say -2 dot your 4. Perfect. Does 4 have a left? No. Does 4 have a right? No. So 4 is done. Next, you get a 5, 0. You get a 5 and you get a 0. So the line 0 will be replaced with 5. So you understand now. You're doing a level order. So first this guy came, then this guy came, then on this you got a 5. So 5 replaced this one, right? So you replaced it on your map data structure. On 5, the left is 8. So 8, on left means -1. 0 minus 1 is -1. And on the right, we have a 9. So 9, +1. So please make sure you put that into the queue. So 5 is also done now. Let's take out the next. That is 6, 0. So you have a 6 and you have a 0 at the same time. So what you can say is the 0 guy will be overwritten by 6. Okay, makes sense. As I said, you will take the rightmost on the level order traversal, that is 6. So you take up 6, you replace it. Does 6 have a left? No. Green color. Does 6 have a left? No. Green color. Does 6 have a right? No. So 6 is also done. Next, you get 7. 7 is at line 2. So line 2 will get someone as 7. Perfect. Does 7 have a left? No. Does 7 have a right? No. 7 is also done. Next, you get 8, -1. So -1 gets replaced by 8. 8, -1. Does 8 have a left? No. Does 8 have a right? No. That's done. Next, you have a 9 + 1. So +1 gets a 9. 9, does it have a left? No. 9, does it have a right? No. So 9 is also done. So at the end, you can see the queue becomes empty. So if the queue becomes empty, right after that, since you took a map data structure, it will always store which key first. Like if I ask which key is that it's stored as first, the -2 key will be stored at first in your map data structure. Map stores in sorted keys, right? So -2, 4. So you got the first view as 4. Next will be -1. So -1 has stored 8. So you'll get 8. Next you will definitely get 0. So 0 is storing your 6. So you got 6. Next you will get 1. The 1 was 3 and that will be replaced by 9. So 1 will be 9 for you. So 1 will be 9. Then you'll get 2. That's 7. So this is how you get the bottom view of binary tree. Just hide it on the map. So it's a very simple thing. Make sure that whatever line you're getting, just replace by node in your map data structure. That's what you have to do in order to get the bottom view of binary tree. So this is how you do it using a level order traversal. So as usual, the C++ code is on the left and the Java code is on the right. So I have a bottom view, right? I have a bottom view. So it's given as root. So what I'll do is I'll take the vector as answer, which is going to store the bottom view. And the root is null, like the tree is empty, I'm going to return answer. Right after that, I have a map data structure. I have a queue stores a node and an integer, like where over here I've made sure, like over here in Java, I haven't stored it because the root.hd, basically what I've done is in the binary tree, in the node, I've inserted a variable int hd equal to 0. Like I've inserted a variable in the class itself. You could have done this in your tree, this also, but again, on your, like if you're implementing Java, you can either have a node hd insert in that node, or you can create a pair class also. That's your wish. Again, implementation, I'll leave it to you. So what I'll do is I'll have the level order traversal till queue is not empty. I'll take the node and I'll just make sure I'll have the line, and on that line I'll make sure I'll insert the node. Done. Right after that, get the left if there is, and insert line -1, and if there's a right, insert line +1. Keep on doing this, and on doing this level order traversal, at the end just iterate on the map and take the second. Take the second means take the value. Take the value, right? Once you get the value, you can return your answer, which is ultimately going to be your bottom view. So this was level order traversal, the iterative version of traversal. Now if I ask you, will a recursive traversal work? You might think, yes, Trevor, we'll just do left, line -1, and we will just do right, line +1, and that will work. But no, the recursive traversal is not going to work with this simple logic. You have to induce some other logic. Why, you might ask? The answer to this is very, very simple. Now just imagine if you have a tree something like this. So if you have this tree and you're doing in-order traversal, you go to this route and you will assign this on your map. Right after that, you'll assign this to your map on whatever line you are having. Right after that, you'll assign this to your map. Right after that, you'll assign this to your map. Right after that, you'll assign this to your map. Right? So on line zero, this is line zero, right? This is line zero on recursive traversal. This is line zero. On line zero, you would have assigned this node. What will happen is, since you're doing in order, after that you'll visit this, and after that you'll visit this. So at the end, you are going to visit this node in your recursive traversal. Hence, the line zero on your map will have this node. Yes, will have this node instead of having this node. So you have to induce extra logic if you're using a recursive traversal. That's why it's better if you implement the level order traversal, because it's very simple and you do not have to keep a track of height, or else you have to keep a track of height also along with line. If you're introducing a recursive solution, please make sure you keep a track of height. The guy whoever is at the bottommost position is what you will always take, right? So please make sure you follow level order traversal. And the time complexity for level order traversal will be big O of n. The space complexity will again be big O of n, and this depends on the structure of tree. That's what the time complexity and space complexity will be. So I hope you've understood the entire explanation as well as the code.
Function to the list containing the bottom view of the limit. No. Yes, I 22, 8, 32, 3, 5, 4, 33, 33. Cheers. Did you imagine? चलो Egyptian handler. Yes. कि मिलाए कभी अखियाँ चुरा क्या मैंने किया जादू Done, guys. मैप हो गया प्रायोरिटी क्यू हो गया प्रायोरिटी क्यू now run this code run it up in case of multiple value for index we need to take only one leader only one override don't know how much test is passed, but most. I just wish. Hmm, Thanks. Thanks. Plan for plan for unit test release deploy operate month. That's the no, I think this is good. Never spoken units component based architecture single page application virtual application that fast scale application are usually travel playlist graphs.
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the problem rotten oranges. What is the problem state? The problem states we'll be given a grid of dimension n cross l. That means a 2D matrix will be given of size n cross l. Now they are saying that 0 means empty, 1 means the cell has fresh oranges, and the cell is marked with 2. It means the cells have rotten oranges. Now you have to determine what is the minimum time required to rot all oranges. That means you have to figure out what is the minimum time that you need in order to rot all the oranges. So how will the oranges get rotten? So if there is a rotten orange at any given cell by index ij, it can rot all the other fresh oranges that are at up, down, left, right in unit time if they are fresh. Now let's understand the question in depth. So imagine this, like, because this is 2, this is a rotten orange, and this is connected to this, and this. Well, this is only a fresh orange. So these fresh oranges will be rotted in the first second. It says in 1 unit of time, it will rot the neighboring guys only. So after 1 unit of time, this is the state of all the oranges. Okay, and the next, what will happen in the next step? This guy has already rotted all his neighbors. So there is this orange step. This orange has this. So this will rot in this and this. So in time two, this orange and this orange will rotten all its neighboring oranges. So it goes down, rottens this, goes down, rottens this. Right now we have this guy here. So this is already rotten, and this guy is 0, which is an empty cell. It does not have an orange, so you cannot rotten it. So apparently, right after time equal to 2, these couple of oranges.
Wait. No, it's doing good.
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the problem that index ij. It can rot all the other fresh oranges that are at up, down, left, right in unit time if they are fresh. Now let's understand the question in depth. So imagine this, like, because this is 2, this is a rotten orange, and this is connected to this, and this. Well, this is only a fresh orange. So these fresh oranges will be rotted in the first second. It says in 1 unit of time it will rot the neighboring guys only. So after 1 unit of time, this is the state of all the oranges. Okay, and the next, what will happen? In the next step, this guy has already rotted all his neighbors. So there is this orange step. This orange has this. So this will rot in this and this. So in time two, this orange and this orange will rot in all its neighboring oranges. So it goes down, rottens this, goes down, rottens this. Right? Now we have this guy here. So this is already rotten, and this guy is 0, which is an empty cell. It does not have an orange, so you cannot rotten it. So apparently, right after time equal to 2, these couple of oranges did rotten the neighboring oranges. After that, now these are the new 2 oranges. So can I see this guy has no one? Yes, but this guy has someone on the bottom. No one over here, no one over here, no one over here, but someone on the bottom. So I can say at time equal to 3, this guy will be rotten. Perfect. What about time right after this? Now, this guy is the new rotten orange. Has something like this. So this guy will be rotten now. So at time equal to 4, this guy was rotten. So what is the time that you required to rotten all the oranges? That is 4 seconds or 4 unit of time is what your answer will be for this particular question. So let's take another example. So this is an example, and if you see in the starting, there are 3 rotten oranges. Yes, in the starting there are 3 rotten oranges. So if I say at time equal to 1 second, what will happen? This rotten orange will rotten all its neighboring oranges. This rotten orange will also rotten all its neighboring oranges. This orange will also rotten all its neighboring oranges. So what will happen is this guy has this neighbor, this neighbor, this neighbor. Out of this is just the single fresh orange. So it will rotten. Now time for this guy, and it happens simultaneously. Like when this guy will rot in this orange, this guy will rot in this and this simultaneously, right? So what will happen is this guy will rot in this and this. After this, there is only one orange left, which is this, which is rotten. This guy will be like something like this, so it will be rotting this. Done. So I can say right up to 1 second, this guy rotted this guy rotted this, and this guy rotted this. So apparently, if you carefully see, are there any fresh oranges left? That is no. So the answer is in 1 unit of time, I was able to rot all the fresh oranges that were there in the matrix. So let's take one more example. So if I just have a single rotten orange to start off with, so this will be rotting this guy, and this guy. So please rotten it. Rotten. So this will be the case at time equal to 1 second, right? At time equal to 2, what will happen? The new oranges that were rotten, they will rotten. So this was rotten, they will rotten its neighborhoods, which is this. Then this guy will rotten its neighborhoods, no fresh oranges, nothing to rotten. Then this guy will rotten its neighborhood, no fresh oranges, nothing to rotten. So apparently at time equal to 2, these 3 guys rotten all their neighboring oranges. Right after this, we have another guy left, right? So this guy does not have any neighbor. Done. So at time equal to 2, they rotten it because after that, there are no neighboring oranges to be rotten. But even after this, we see there is one guy left who is a fresh orange. But is it reachable? No, it is not. Why? Because the movements are only like this. So a rotten orange can only rotten someone at the top, someone on the right, someone on the bottom, someone on the left. You cannot rotten someone who is at a diagonal or is at a distance. You need to be attached to them in only these 4 directions to get rotten. So as of now, I can say this is not possible, and if it is not possible, you return -1 as your possible answer. So if I ask you a very simple question, which algorithm should we use? So we have 2 rotten oranges, and I can say it does rotten its neighbor at the same time, which is 1 second. So it is similar to say these guys were at a distance of 1 or at a level 1. So each of them got rotted at a similar stage. And if you're visiting same level guys, because this is at level 1, level 1, level 1, same level guys at same time, what algorithm do you use? BFS, because this is the only algorithm that traverses level wise. Had you gone something like DFS, what would have happened is Fred would have gone from here to here, then to here, then to here, then to here, then to here. which would have taken you 1 second, 2 second, 3 second, 4 second, 5 second. If you would have used DFS, which is depth first search, you would have gone in the depth and you would have visited all the neighboring fresh oranges. But you need to make sure you require minimum time. Over here, it's not like you need to rotten all the oranges. Over here, it is like you need to apply the minimum time, and that is only possible if you move in the neighboring directions at an equal pace. Right? So that is what we will do. This is the intuition behind BFS algorithm, because we want to rotten them simultaneously. That is why something like an BFS algorithm will be used. So do you remember the BFS algorithm? Yes, you do. What is the initial configuration? Yes, it is a queue. So you can always define a queue. And in the initial configuration, you can always say that over here we have couple of starting points, or the number of starting points will depend on the number of rotten oranges present initially. And these are the two rotten oranges which are present initially. So if I just number them, the row number will go like, the first rotten orange is at 2, 0. The next rotten orange is at 0, 2. So you can easily just pass on this. And remember this, what is the other thing that we require? A visited array. So probably you can create a visited 2D matrix. So go ahead and create a visited 2D matrix. Done. Over here you can say the two rotten oranges that you pushed in, you can easily mark them as 2. Done. Now, I need the minimum time, right? I need the minimum time. So what you need to do is, you need to always see that, hey, listen, when these guys started, it was the initial time. So you need to carry one more variable, something like 0 with these guys, saying at a 0 time, these were the guys who were rotten. Okay. Right after that, what you'll do is you'll say, okay, 2, 0 is the row on the cell number, and the time is 0. Now, if I go to 2, 0, this is what it is. Now we go to its neighbors. Who are its neighbors? These are its neighbors. Invalid, invalid, empty cell. Only one neighbor is having a fresh orange. Take up this neighbor, put it into the queue with a time of 1 second, because you will be taking one more second than the previous time. So you'll put them into the queue. At the same time, make sure you rotten it over here. Done. What's the next step that you'll do? You'll take, this is done. The next time you'll take 0, 2, and the time is again 0. Okay. And now what you will do is, you saw, okay, at 0, 2, the time is 0. Okay. So where is 0, 2? Here. Who are its neighbors? This guy invalid, this guy invalid, this guy afresh, this guy afresh. So there are two fresh oranges. So you'll just pick up those two fresh oranges. First one being 1, 2, 1. So 1, 2 is the fresh orange, which is this, and the time is 1 second. Over here it is 0 and 1. So you pick up 0 and 1, and this will be 1. Perfect. This is also done. At the same time, please make sure you mark them as rotten. Next, 2, 1, 1. The time is 1. Now we are taking time equal to 1. Probably you can keep a variable which keeps a counter of the maximum time. So the maximum time as of now is 1. Right? The maximum time as of now is 1. So we have someone as 2, 1. Where is 2, 1? This portion is 2, 1. Who are its neighbors? This guy, a fresh orange. This guy, a fresh orange. This guy, invalid. And this is already rotten. So I found two fresh oranges. So go ahead and rotten them in the next second, which is 2. And over here at 2, 2, and rotten. And make sure you mark them as visited. Perfect. This is also done. At the next, we take 1, 2, 1. This is the time equal to 1. Whereas 1, 2, let's write it. 1, 2 is here. Already rotten, invalid, already rotten. So there is no fresh oranges remaining. So done with this as well. Next you get 0, 1, 1. Where is 0, 1, 1? Here. Who are its neighbors? Already rotten, because over here you can find that they are already rotten in the visited arrays. So no more neighbors of this guy. So this is also done. Next time you get 1, 1, 2. So you got someone who took 2 seconds. So you can see the time to be updated to 2 seconds. Now at 1, 1, 2, again if you see, this is already rotten, this is already rotten, this is already rotten, this is already empty. So you find already rotten by this. So no one again. This is also done. The next time you get 2, 2, and the time is 2. So the time is already 2. So if you see 2, 2, up 1 already rotten, invalid, already rotten. So I can say this is also done. So at the end of the day, I can say the queue turns out to be empty, and I have always visited all the cells. I've already visited all the cells. So let's see, did all the fresh oranges got rotted if we started rotting from these two? Let's see. This was a fresh orange. Is it rotten? Yes. This was a fresh orange. Is it rotten? Yes. This was a fresh orange. Is it rotten? Yes. This was a fresh orange. Is it rotten? Yes. This was a fresh orange. Is it rotten? Yes. So all the fresh oranges were rotten. So I was able to rot all the fresh oranges. And what is the maximum time I took? The maximum time I took was 2 seconds. So this is going to be my answer. If any of the fresh oranges were not rotten in the visited array, you could have printed -1. You could have easily printed -1. So as usual, I'll be coding the C++ code, and you can find the Java code on the left so that you can easily follow. So what do we need at first? We have the grid, right? right? So please just make sure you figure out the NNM because that will be required going forward. Just make sure you figure them out. Okay, fine. NNM has been figured out. What is the next step that we did? We always said, get me all the rotten oranges and put them into the queue. So what you can do is, you can store them into the queue, something like a pair. So this guy will be storing the row column, and then you can store the time. So this is how you can have the queue. It's basically going to store something like this. Okay, it's over here the row, column, and over here the time. So this is how the data structure looks like. Next, you can always declare something like a visited array. Perfect. So declare this visited array. Okay. What you will do is, you will be traversing across the grid and get all the oranges that are rotten. So just travel. And over here you can say if grid of I j is equal to 2, that means it is rotten. And if it in case is rotten, I will say q. Can you just take these guys because these are rotten, and at time 0, please take them, right? So this is something which you will always do. So once you have done this, what is your job? You also need to make sure that these guys are marked as rotten at the visited. So this is also done. Right after this, you need the time to be computed. So initially you can keep it as this, and now you know you will always write the BFS. This is how the BFS is written, and you can always get the first row as q dot first, and in q the front element is front. So yeah, that's how you'll get it. Right after this, you can always get the column as q dot front dot first dot second. Again, follow this particular data structure, guys. Follow this particular data structure. First dot second. And what will be the time? The time will definitely be something like q dot front and be at the second. Done. After this, you can do q dot pop. Once everything is done, you need to visit all the neighboring guys. So if I go back and write all the guys, we have a row column, right? So at the top, at the right, at the bottom, at the left. So at the top, we have something like row minus 1 column. At the right, we have something like row, comma, column plus 1. At the down, we will have row plus 1 column. At the left, we will have something like row, comma, column minus 1. Correct? So this is at the top, this is at the right, this is at the bottom, this is at the left. So can I say there is a change of minus 1 and plus 0 when we go at the top? Can I say over here there is a change of plus 0 and plus 1? So if I probably write something as a delta row equal to, if this can be an array, minus 1, 0, plus 1, 0. And I can write delta column as something as 0 plus 1, sorry, my bad, yeah, plus 0 and minus 1. Perfect. And now can I say, on the row, if I add this, which is minus 1, on the column, if I add this, I will get the topmost one. Similarly, if I on the row add 0, which is row, and if I add plus 1, column plus 1, I'll get this. Similarly, if I add these, I'll get this. Similarly, if I add this, I'll get this. Can I see? I can definitely see. So what you'll do is, you'll just simply create this delta, guys. It's very simple. You can say d row, and you can create something like minus 1, 0, plus 1, 0. And you can similarly create something like d column, right? And d column can also be have something like 0, comma 1, comma 0, comma minus 1. Okay. This is how you can easily get the d row and d column. So how many neighbors are there? There are exactly 4 neighbors, so you can easily traverse for them. So what will be the neighboring row? The neighboring row is going to be very simple. It's going to be the initial row and the change, which is d row, delta row of I, will be the neighboring column. It's going to be the column plus the d column. Perfect. So this is how you can easily write it. Please make sure you maintain variable namings because code quality is very, very important. Right after this, you can say, okay, is this valid? Okay, is this valid? Okay, is n column valid? Have a check always. Is n this valid? Once they are valid, I need to check, I need to make sure, are they previously not rotten, which is neighboring row, neighboring column. Are you previously not rotten? That means, are you not visited previously? If you are not, and are you a fresh guy? Because if you're not a fresh guy or you are an empty cell, I don't go. Are you a fresh guy? If you are a fresh guy and if you are not rotten, then you are one among me, and I can easily put you in the neighboring row in the queue with an timer increased, right? So the timer will increase. At the same time, I can say the visitor to say, okay, these are my guys. Can you just mark them as 1? Once this is done, I'm getting the time every time. So every time you get the time, just make sure you store the maximum, because whatever maximum you take, that is what you'll store. So just make sure that over here, if it is not a rotten orange, mark them as 0 because it is very, very important that you initialize the visited one. And once queue is done, you can return the timer, but before that, you need to do a check. So before returning the time, you need to check if all of these fresh oranges which were initially fresh, were all of these converted into rotten or not. If it is not, something like if visited of ij is not equal to 2, and on this grid it is a fresh orange. If all the fresh oranges have not been converted, you return a -1. This is a check. If it is not, this is, now let's submit this. Now you might argue, but Trevor, why did you check at the end? You could have applied a different logic where initially you can keep a count. So what you can do slightly different is probably over here do something like grade of ij equal to 1 and keep a count of fresh. That's it. So you can always keep a count of fresh over here. And so if you kept initially a count of fresh, okay, so what you can do is, okay, you kept a count of fresh. So every time you're getting a fresh orange, you are pushing that into the queue, correct? So what you can do is you can just keep a count over here. Every time you're getting a fresh orange, you're pushing that into the queue. So the end, if the counter is not equal to all the count fresh, it means you did not push them into the queue or you did not touch. So you can just return a minus one. You can also do this, and this will also be running fine. So even if you submit it via this count fresh method, it still runs fine. So yeah, these things you can do. You might argue, Trevor, instead of visited, I can use the grid only. Yes, you can do that. But I always say, whenever some data is given to you, do not alter it. Because in industry, if someone is giving you a data to perform something, you don't change the data and work an algorithm on it, right? Just take this data and you work on it, basically copy of it. So that is why never ever alter something which is passed by reference or something like this, because that is the data that is given to you. Okay, so this is how the code will look like. So if I talk about the time complexity, or let's first talk about the space complexity. We are using a cube, so how many total nodes or total oranges it can have? All the oranges can be rotated, which will mean that we will have n cross m oranges. So n cross m will be the space over here. And you're using n cross m over here as well to visit it. So you can say that overall it's like n cross m as the space that we are using on an extra basis. So the space complexity can be said to be n cross m. But what about the time complexity? We are at first running n cross m loop, so n cross m. Then we know at total the queue will run if all the oranges are rotten. Sorry, all the oranges are fresh. Then it will run for n cross m, because that will be the number of times you will put them into the queue, so the queue will run for that. And for every guy, we are running 4 times. So for every node, like for all the nodes, we will be running for 4 times this loop. So again, this can be aggregated to n cross m only. That will be the time complexity if we aggregate this. So guys, I hope I was able to make you explain this tough question. So just in case I was, please make sure you like this video. And if you're new to our channel, what are you waiting for? Hit that subscribe button right away. And yes, if you haven't checked out our DP series and the SG sheet, the links are in the description. Please make sure to check them out. And with this, let's wrap up this video and meet you in the next one. Till then, bye-bye. Take care. Whenever your heart is broken, don't ever forget you're golden.
Orange, orange, green. Yo, sup? Problem number 994. 994. Breakfast. Breakfast search. Breakfast search. Breakfast search. File. Tick tick one. Tick tick two. Tick tick three. Let's see. Grid length 0 है. Obviously we don't zero है. Coding is such a boring task, buddy. Initially, this one is rotated, then this side, and again this side. नेक्स्ट मिनट में again ये rotate करेंगे and ये similarly ये Julia account fresh. Just move all button. Again, one. Curiosity. गलत हो गया गलत Why? This is not working. Hmm. ऐसे जुड़ूं तुझसे मैं भटकता हूँ। Francisco Pranita. Yeah, thanks. Kachamania. Wildliner.
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So in this video, we are going to solve this word ladder 1 problem, which is an extremely hard problem. So what does the problem state? The problem states you're given two distinct words, two distinct. So a start word and a target word, and a list denoting word list of unique words of equal lengths. Find the sequence from start word to the target word. Now you need to keep the following conditions in mind. A word can only consist of lowercase characters. Only one letter can be changed in each transformation. Very, very important. Each transformed word must exist in the word list, including the target word. The start word may or may not be part of the word list. So, what does this particular problem define? So, it defines it given a begin word. So, over here it is hit. They given an end word. Over here it is hawk, and you're given a word list which will be containing certain number of words, and if you see all of them are of length 3. So if I start with hit, so let's start with something like hit. Now what you can do is you can change any one of the character. Like there are 3 characters in hit. You can change H, you can change I, you can change T. You can change any one of the characters of hit. So as you might say that, hey, I'm going to change this I to O. So what I'll get is hot. And if you carefully see, hot is there in the word list. So you can have this transformation done. In the next step, I say I'll change hot to dot, which means I'm going to change this H to T. And you see dot does exist over here. In the next I say I'm going to change dot to doc. Basically I'll change T to G, which is dog also exists in this particular word list. In the next, I'll say I'll change dog to, I'll change the D and I'll make it C and I'll have a cock, which is nothing but our end word. If you carefully see, this is nothing but our end word. So if I ask you how many transformations did you do? There was like 1, 2, 3, 4. And what is the sequence length? That's 5. So thereby I can say that this is the shortest transformation sequence if you want to start from head and you want to end at something like a cock. So if I show you one more example, over here we have the word list as DES, DER, DFR, DTT, DFS. So DER can actually be changed to DFR, and DFR does exist if you see, and then DFR can be changed to DFS, and DFS also does exist over here. So over here the sequence is of length 3, thereby the output is 3. Now it might, now what if it is not possible to change a particular given word to any other word? In that case, you will just return 0, stating that it is not possible. The sequence length is 0. Now you must be thinking which algorithm to apply. But before going into that direction, let's analyze the problem. We're given hit, right? So what can we do to this hit? So hit is getting converted to something like hot, where the I is changed to O, right? So the second alphabet in the word is changed. So if I say hit, where can I change? You can be like Striver. I can change the first H. Striver. I can change the second I. Striver. I can change the third T. Makes sense. Now, let's go deep. If I ask you, if you change H in hit, what can you make H as? You'll be like, I can change H to AIT. Makes sense. I can change H to BIT. Makes sense. I can change H to CID. Does make sense. I can change H to DIT. Makes sense. I can change H to RIT. Makes sense. I can change H to ZIT. So ZIT does make sense. So apparently, in the head, I can pick up the first character and I can change it to anything from A to Z. Do you agree? You do agree, right? Similarly, can I say I can pick up I and I can change it to anything from A to Z. Do you agree in this? You have to. And when I change I to O, I get hot, and that hot does exist over here. If you see, the hot does exist. So apparently, you can try changing like HAT, HBT, HCT, HET, HFT, but the only one valid will be hot. Why? Because that exists in the word list. And the next step you can be like, I can change T as well. T can be changed to A to Z, and what has to be the word list. Agreed? So This is the brute force that we will follow. We will start with a particular word and we'll try changing it on character to character. And every character we will replace from A to Z and we will see if it is in the word list or not. Alright, so as of now, you know the brute force, right? So if you know the brute force is pretty simple. You have hit, you take H, and you try to change it from A to Z. You take I, you try to change it from A to Z. You take T, and you try to change it from A to Z. And you count the minimum length. Yes, you count the minimum length because the question states you have to find the shortest transformation sequence. So you do it, then you find the shortest transformation sequence. Now, which algorithm to apply if you are willing to find the shortest sequence? Let's analyze that. So if I say I will keep the hit as the level 1 right at the top. According to brute force, I try to do H to AIT, BIT, CIT, DIT, and so on till ZIT. I'll try to do this, right? In order to transform.
Let's pause this, guys. And I'd like to share my screen, buddy. No. There's nothing wrong. So, think about checkmate, guys. Change the promote form. Next. Right to move. Now, tell me, guys. What should why should I be queen? Should point that shit. Why? Sorry guys, bit lag. I it's okay. Very new in chess. Let's do this. Hello. Oh, hi. How the अभी हाँ, अभी तो नहीं खाए खाएंगे थोड़ी देर बाद क्योंकि मन है मेरा और क्या मन है मेरा इसे बताएं और क्या मन है मेरा कैसे बताएं लोगों की और मुंह से बताते हैं अभी थोड़ा देर अभी थोड़ा देर में क्योंकि अभी भूख नहीं कर अभी मेरा मूड ही ऐसा है क्या बात कर रहा हूँ मूड को मारना
Eh, eh,
है क्या हम्म, काहे के गलत बात है बहुत गलत बात भी है काहे किया भाई ऐड बोलो मैं इस काम में नहीं आ सकता क्या बोलूँ गुड वेल डन वेल डन आउटस्टैंडिंग माइंड ब्लोइंग फैंटास्टिक हाँ ओके पता रहा निकाले दोबारा मूड स्विंग अभी ब्लड में अब खाना खाया खाना खाया क्या पूछ रहे हैं लब खाना खाया क्या खाया क्या खाया Okay.